when you see a quadratic like this, one way to factor it is to look at this number and think, okay, I need two things whose product is 6 and whose sum is -5. And this is kind of an easy example where it's -2 plus -3 is -5. We get our two answers. But I want to show you an alternate way that's going to be useful for higher degree equations. So I'll go back to x squared minus 5x plus 6. One way to check to find the factors of something, and this goes not just for polynomials but for numbers also, is just to divide. Like if I have a number like 6 itself, if I want to factor it into 2 times 3, one way I can do that, let's say I didn't know that 2 and 3 are the factors, I divide 2 into 6 and get 3, and if I get remainder 0, then 2 was a factor. And if I don't get remainder 0, then 2 wasn't a factor. Well, you can do a similar thing with polynomials. So what might be a factor of it? Well, remember, when you do FOIL, you have to get this plus 6, we'd multiply whatever these two numbers are together. So what I'll call the potential factors are x minus 1, x plus 1, x minus 2, x plus 2, x minus 3, x plus 3, x minus 6, and x plus 6. These have a chance to work because there's a 6 here. This is assuming everything's integers, because this times this have to become 6, so I need to have either a 1, a 2, a 3, or a 6. I can't have like x plus 4, otherwise I would need some kind of, or x minus 4, I would need some kind of fraction here in order to get the 6 here. So assuming there's no fractions, the potential factors are on this list here. And the thing I want you to observe is that the number after the x is a factor of the 6. This list of potential factors could also be turned into a list of potential roots. If x minus 1 was a factor, then x minus 1 equals 0 would be one of the solutions. So the roots would be 1 or minus 1 or 2 or minus 2 or 3 or minus 3 or 6 or minus 6. So the potential roots are also factors of the constant term. So I could test these 8 things one at a time until one of them goes into this evenly. Let's just see how that looks. You gotta be careful when you subtract here. It's negative 5x minus a minus 2x is negative 5x plus 2x is minus 3x plus 6. Then you put a minus 3 here. And we get a remainder, not remainder 0. Now it's kind of tiring to do all that, so we might want to use something called synthetic division. Here I'll redo the same question with synthetic division. You put a regular 1 here instead of negative 1. This is how we're checking. This is how we're dividing x minus 1 into x squared minus 5x plus 6. Here we put the coefficients of 1, minus 5, and 6. The way synthetic division works is you bring down the 1, then you do 1 times 1 is 1, then you do negative 5 plus 1 is negative 4, 1 times negative 4 is negative 4. That's odd. I would have thought this was going to get us the same answer. Something went wrong. This, because this is a 1x. And this is a minus 4x. This is a 4. Sorry about that. Minus 4x plus 8. Okay, still does not have remainder 0. and then we get this thing was supposed to be a plus 4, and 6 minus 4 is plus 2. See these three numbers here? That means the answer is x minus 4 is the quotient remainder 2. And so that's not one of the answers. But if I were to try dividing by x minus 2, which I know is one of the answers, 2 times 1 is 2, minus 5 plus 2 is minus 3, minus 2 times negative 3 is minus 6, 0. So this would mean that x squared minus 5x plus 6 is equal to x minus 2. The fact that I got a 0 here means that x minus 2 is a factor, and the other factor is x minus 3. Now this does not seem like a great way to solve this question, but it's going to be useful for cubic equations. I also want to mention quickly that there's something called the remainder theorem, where that says if you have a function, and the remainder theorem says that f of a is equal to the remainder when f of x is divided by x minus a. So remember before we had this, and we divided it by x minus 2. We did it with synthetic division, and we got, sorry, divided by x minus 1, I mean. And we got a remainder of 2. Well, they're saying that if all we care about is what's the remainder, we could just do f of regular 1 and get 1 minus 5 plus 6, which equals 2. It also means if I want to know the remainder when I divide by x minus 2, I say f of 2 is 4 minus 10 plus 6, which equals 0. No remainder means that it's a factor. So you could check to see if something's a factor by just, you could just plug in to this equation. On the other hand, if you want to know what the remainder is, if you want to know what f of something is, you could also do synthetic division. Depends which thing you think is easier. Is it easier to plug in, or is it easier to do synthetic division? Sometimes it's about the same, but you have that option. So if they ask you what's the remainder, you could do synthetic division, or you could plug in f of 2. On the other hand, if they ask what's f of 2, you could plug in, or you could do synthetic division. Either way, it depends which one's easier for you at the time. Okay, here is a cubic equation, and it's not easy to factor this, so I'm going to show you a trick here. The potential roots are factors of, this is if there's no coefficient besides 1 out here. The potential roots are the factors of the constant term. So there are 6 potential roots. This is because it's like, if I actually was able to factor it, there'd be a constant here and a constant here, and they'd multiply together to become negative 6, and this thing here would tell us the factor, which would tell us the root. So one way of doing this, and this might not have any roots, but it might have up to 3 of these numbers here. So I'm going to show you how you would use synthetic division to check. Okay, so to check to see if x minus 1 is a root, is a factor. Here are the coefficients, 1, 2, negative 5, negative 6. See, I'm putting a positive 1 here. Those is the opposite of this. 1 times 1 is 1. That becomes, add them to get 3. 1 times 3 is 3. Add them to get negative 2. 1 times negative 2 is negative 2. Get negative 10. A couple of things happen. The fact that this is not 0 means the answer is no, this is not a factor. It also means that f of 1 is equal to negative 10, which might or might not be useful. Let me check now if x minus 2 is a factor. Put a 2, regular 2 there. 1, 2, minus 5, minus 6. Synthetic division, 2 times 1 is 2, that becomes 4. 2 times 4 is 8, that becomes 3. 2 times 3 is 6, that becomes 0. So the answer is yes. A couple of things now. We know x minus 2 is a factor, because that became 0. We know f of 2 is 0. That's what happens when you have a factor. But we also have these guys. That's the other factor. And good news, this thing here can be factored to x plus 3 times x plus 1. So that's how you can factor. Sometimes this thing here doesn't factor, so you just get this one factor. But that's a way you can know what things have a chance to be a factor, and then you test them until you find one that gives you no remainder, then you found your factor.